Thank you. Good morning, everybody. I can see we are running out of seats, so I guess that's a good sign. My name is Miika Pylvänäinen. Just call me Miika. My last name is difficult even for some Finnish people, so I don't blame you on that. You did quite well, actually. Thanks. As said, I've been working with Confidex now for the past 15 years, coming with a bit more technical background, started in R&D, and now leading our product management at Confidex. And today I will talk to you about RFID applications in automotive. We have already heard very nice presentations about the topic, and this mine will be kind of an overview of the whole applications. We could spend the whole time for one single application here, and I'm happy to do that after the presentation, but this will be kind of a quick overview of different applications where we actually use RFID. But first, very quick introduction to Confidex. We were established 2005 in Finland, and we have grown into what we call a global player in short-range wireless product solutions. I will get back to that. Industrial use cases have always been kind of the focus of Confidex, automotive, manufacturing, logistics. But also, if you have been traveling in Amsterdam, Venice, or any of those other 120 cities that we deliver mass transportation tickets to, you actually have used already Confidex product there. Just you didn't know that. Quality always been kind of in the DNA of Confidex, and therefore we also design and manufacture all our products by ourselves to have that quality overview from the design to delivery and everything in between. We have offices all around the world, but now with the recent acquisition by Beontag, we are expanding our global presence, not only with the production sites, but also with more local support to our customers. The countries shown here, they illustrate the Beontag facilities, but of course all the gray countries, those are covered by our partner network, so you do have a local support also there. Now together with Beontag, we are able to support automotive customers not only with these industrial Confidex products, but also with more sustainable paper-based products from Beontag catalog for short-term logistics applications. I mentioned earlier that we focus on short-range wireless solutions. Well, so what is that? For us, this means RAIN RFID, NFC, and BLE technologies, all very relevant for automotive. You can use RAIN RFID for logistics and production control, NFC for applications where you have more consumer interaction, and then BLE for use cases that requires a bit more advanced locationing or active sensor capabilities. All very relevant for automotive, but today we will not cover the technologies themselves more than this. So let's jump into the actual topic. I will cover 6 different applications today in a bit more details. Why would you use RFID there? What are the benefits? And let's start with so first one here, supply chain and container management. This is basically tracking returnable containers or single-use disposable packaging along the whole supply chain. Parts tracking for prototype parts and mass production parts. Production control, which is of course quite broad application. It can include tooling, mold tracking, all the way to the actual vehicle identification in a production line. Distribution, outbound of finished vehicles. Life cycle and mobility services, basically after sales use cases. And then one that I wanted to specifically separate from the others, tire tracking. This, of course, is kind of a parts tracking, but embedding RFID into a tire is quite different kind of challenge. So I will talk about that in a bit more details. Why would you tag tires and how to success in those projects? So let's start with the supply chain and container management. In a nutshell, this is inbound, outbound logistics and inventory management. And within this use case, we can basically split the tag implementation into 3 different categories. First, we are tagging the containers with the permanent tag, something that would look like this, something that is designed to withstand the lifetime of the container. Secondly, we are tracking the KLTs, the plastic boxes with the single-use Kanban card, something like this here. Or third, we are simply tracking the disposable packaging, cardboard boxes, metallic cans with a disposable RFID tag. Now, benefits for using RFID in your supply chain, they are quite easy to find. Of course, transparency is what we are all after. We want to have better, improved transparency throughout the whole supply chain. But this then brings other benefits, like just-in-time deliveries and optimized inventory levels, for example. Mitigating shipping errors is a big reason to use RFID, and we will get back to that also. Now, sustainability is a big and very important topic, and all the actions that are reducing unnecessary shipments, making processes more efficient, they are reducing carbon footprint. So in a nutshell, RFID itself is already very sustainable technology to use. From product perspective, I also want to add one comment here. We often talk about only these paper-based products when we talk about sustainability, sustainable products. But when you think about a product that is designed to withstand the whole lifetime of a container, like this one here, that's already quite sustainable product in itself. Now, I'm an engineer. I'm not a salesperson. You may tell that. So why I have enjoyed this RFID ride for more than 15 years already is the customers. They are very different. Anyone could be our customer. And they have very different kind of challenges, different kind of needs that they have. If we are taking cars on production line, or we are tracking, let's say, trees on some banana plantation, they are quite different kind of environments. So that's what's interesting for me in this whole business here. Now, when we look at the actual use cases, I want to introduce this kind of tag selection graph to show you what were the important product features, why this project was successful, what customer highlighted. So we will get back to this graph with the use cases. When you're selecting a tag, you always have to balance between these features. If size is important, if you want to have a small tag, you need to sacrifice performance. That comes with the size. Or if you want to have a very robust tag that you can hammer, it's not going through printers, no matter how hard you try. So you have to sacrifice the printer compliance there. And all these are then, of course, affecting the total cost of the tag. So very important to consider. Now let's take a look on one use case for supply chain and container management. Here we have a German OEM that is using these e-Kanban labels for improved inventory control and just-in-time deliveries. You may be familiar with the traditional Kanban process. It's been used already for 70 years in automotive. So now we are just making that better, faster, more efficient by RFID enabling the standardized Kanban cards. From these product considerations here, you may think that this simple tag, there's not many requirements, but when you add there printers and applicators that you need to comply with, video recommendations for dimensions of a tag, attachment method, it needs to go to this card holder of a container, and read range to be able to read the tags also in this kind of smart shelf application where the reader is on top and you read all the containers in a shelf. You end up actually ticking almost all of these. Only environment is the one that is not chosen, but actually that affects because we chose the paper materials because of the environment that they don't need a robust tag there. Goodpack is world's largest provider of intelligent metal containers, IBCs as they call them. And they operate globally through over 400 warehouses, 5,000 locations, and they are supplying RTI services for automotive, for example, also other industries. And they have tagged more than 4 million of these containers with the tag shown here in the picture. And if we again look at the graph, read range is very important. They want to read 12 of these containers all stacked, folded together when they are passed through the reader portal. Environment, again, we have to withstand everything that this kind of metallic container goes through, and you can imagine all the washing processes and forklifts hitting and everything, so rather challenging environment. Why they are taking these inbound, outbound logistics of the containers? It just makes the process much more efficient. And this is pretty standard and well-proven RFID use case already today in many industries. On this photo here, we also see a laser engraved barcode there. And this is something we do quite a lot for our customers. In this case, as they have 5,000 locations, and not every single location has RFID reader. There can be a location that only handles one container a week, so it makes no sense to really invest. So they can still use the slower barcode as alternative technology when RFID there is not needed. Parts tracking. We started years ago with prototype part management, but now we have obviously moved into production parts tagging, and this brings then several other use cases. For example, identifying the correct parts during the production of a car. In some case, you can also use the tag for the quality control reasons during the assembly process. And benefits of tagging parts, they are mainly related to automatization of the whole process. And obviously inventory levels. You know exactly how many parts you have in your warehouse, how many parts you have in a staging area. With transparent supply chain, you know how many parts even your supplier has in their warehouses. And also having more automated way for documentation of the safety critical parts. This can be airbags, brake control units, something that you need to track during the process. And automatically documenting the assembly of that part is something that many of our customers are looking after. Dana is a Fortune 500 company, and they are producing drivetrains for many automotive companies, Stellantis, Ford, Volkswagen, Toyota, to name few. And they had a need to track the drive shafts and needed a very narrow ornamental label there. You can barely see the label here in this picture. That was cost efficient, but still can go through the over-painting cycle. So all these drive shafts, they get painted during the process. And now having an automated way to identify every single part in a process, production, it of course saves a significant work time and cycle time. And you have the 100% traceability of the parts, including the third-party production sites, like the painting in this case was done by a third party for Dana. This kind of customization is quite common that we do. Unfortunately, there's no product that would be perfect fit for every application. That would make my life a lot easier, but honestly quite less interesting, so I'm happy with those challenges and customizations. Honda is using RFID to track the engines in their processes by tagging the engine racks, so not engines themselves, but the racks that are used to ship those engines. Again, we come to shipping errors. So they did ship wrong engines to wrong location, which can be quite expensive mistake. So with RFID, they were altogether able to reduce, or not reduce, but eliminate those shipping errors. And ROI is quite easy to calculate when you know the shipping errors with more manual way and compared to not having those. Safety is very important topic for any manufacturing environment. And having more automation, it always improves the safety. For example, in the past, the forklift driver, they had to jump out from the vehicle and check the engine that it's correct one before shipping. But now with RFID, they don't. So this directly, it reduces the accidents that happens in a production environment. Production control then. This is of course quite broad application. As said, it requires all these other applications to build an efficient production process. But here we are more focusing on the car body itself and tracking that and controlling production from that point of view. And when we talk about body identification, there are basically two different scenarios. Either we are tracking the bodies themselves or we are tracking the skids that are carrying the body throughout the production. And when tracking the body, there are also some scenarios that you may want to introduce what we call a second body tag. If you have a tag on car chassis, you put some metallic on top of that. It's the nature of RFID that you're not able to read through metal, so you might need to add there what we call a second body tag. And this could be, for example, a tag on a bumper. Then you just match those two tags and use the bumper tag going forward in the process. Using RFID in a production process, obviously, it increases the flexibility. Today, every car that comes out, they can be a bit different, depending what customer has orders. There's a lot of customization that you can do when you order a new car. So RFID helps to manage this kind of complex production process. Volvo is tagging every single car that they produce with our tag. And what is actually quite cool in here is that the first component that is attached on a car chassis at the beginning of the production is our tag. Then it follows the car chassis throughout the whole production cycle, including the electronic bath and drying ovens. We've been developing high temperature tags with Volvo now for a decade or so already. Did many product variations, but then reached 99.96% reading accuracy in their production. You can imagine how expensive it is if the car production line stops because the tag is not working. So you really want to ensure that the reliability is there. From this tag selection graph here, we can see the attachment method was important in this highly metallic environment. Consistent read range, not the read range, it doesn't always mean the longest possible read range. It can be, like in this case, consistent read range. So you want to ensure that every tag reads exactly the same way, that you are reading the car in front of you and not the one next to that one. And of course, environment, the temperature, it reaches more than 200 Celsius during the process, so tag has to withstand that. Distribution. This application is also very common. And there's, for example, a specific VDA recommendation written only for this application. Use case is pretty simple. You want to have easy and accurate information about the cars leaving the production site. The product may be a label like in this car window here with the removable adhesive, or you may use the same tag that you used for the production control, also in a distribution. Like Juho mentioned, there's already many tags in a car, so you can actually use the same tag for different use cases if you just build the process accordingly. One use case is also not to tag the cars, but actually to tag the parking lots. So when operator drives car to a waiting area, they are huge. There's a lot of cars, and sometimes they actually lose the cars. But if there's a tag on a parking lot, you just read the tag when you put the car there, you easily can link the location to a certain car. One company using RFID for car distribution is Ford. They are attaching RFID label already during the production line to the vehicle window. And that is then read at every point after that, when the car leaves the production site, when it's taken to the test roads, waiting area, and at the point of distribution. And this can be a truck full of cars. So usually those cars, they leave the premises with a truck, so you need to be able to read all those cars when they are on a truck. This is a good example of application that, again, sounds very simple, but you see we have ticked all of these features here. You have to have a label that is compliant with printers and applicators. Size needs to follow standardized dimensions. The cars, they can be waiting in a heavy rain outside, even snow, whatever weather, so it has to be robust enough to withstand that. The read range, as said, you can have a truck driving through a gate and you need to read every single car there, so you need to have a certain read range. And at last, the label should not leave any residues on a window when you take the label off. So a label that can withstand a lot, but is easy to remove. So nice challenge to overcome. Lifecycle and mobility services is then, again, a bit different application as we are moving outside of the production environment closer to the customer. We can, for example, authenticate the replacement parts, ensure they are original and not fake ones. EV cars are really booming, as we know, and there we also have different scenarios for battery charging, battery replacement, where RFID can help. One big use case today is automatic vehicle identification. You may have a windshield RFID tag on your windshield label for this use case for tolling or parking applications. And in general, when we talk about applications close to the customer, we also bring in NFC, because everybody has the NFC reader in a pocket, so it's easy to read the part, check it's unique. You might get some instructions related to that part. So NFC is often involved when we talk about life cycle and mobility services. Then the last one, tire tracking. This is an application that I wanted to specifically raise here as it's getting a lot of attention in the industry. There are several different use cases. Of course, the production optimization of the tire manufacturer itself, that's obvious. But already today, vehicle manufacturers, they are using RFID-enabled tires. EV cars, they might have different kind of tires, front and rear, because of the weight balance. So RFID helps there. Inventory management for all parties in the chain, obvious benefit. Tire leasing companies, they can improve their processes. They can ensure that the same tire came back that they leased. This is actually a real problem in some countries, that you actually don't get the tire that you leased back, but you get a more used one. A big part of tire sales went online over the past few years, so having RFID on tires, that helps all those online stores too. But what should be taken into account from product or process perspective when evaluating embedding tire tags? First, you want to ensure that the reliability is there. So testing reliability and read range, you need to spend time on that. It takes a long time, but you need to do that. But in addition to those quite obvious ones, there are also others I wanted to highlight. For example, radiation pattern. Can you read the tag on tire from the rim direction only, or can you read it from the tread direction? Can you read tires when they're stacked for the logistics? Those are things that you need to consider. Consistent quality, is the same batch, next batch of tags reading the same as the previous one. It's a bit of a challenge to test tire tag before it's actually put into a tire, because it's designed to work inside a tire. But there are ways to do this, so this is also something that you need to consider. There are ISO standards for tire tracking, so for the future you want to ensure that you're ISO compliant with your product. And when it comes to the process implementation, there are also different things to consider. What is the best location of a tag in a tire? It has a very big impact on performance. Even small difference inside tire, it can make a half the read range or even more difference. How do you make the whole embedding process without sacrificing a millisecond? Tire production is very lean. They don't allow you to add a second here because of a tag, so you need to adjust with that. Related to that, what is the delivery format of a tag, so that it really follows smoothly or can be fast to embed. How do you ensure there are no bubbles inside the tire due to the tag? How is the tag attached to the rubber? That's also quite a challenge to have a good adhesion there. A lot of small details to consider and gets a bit technical, but as said, I'm an engineer, so I like to talk about this nitty-gritty tech stuff, so I'm happy to continue that after the presentation on our booth. But I think it's about the time, so I want to thank you all for attending this presentation, and I'm not sure, we might have a time for 1-2 questions, do we?
Thank you very much, Miika. And we do indeed have time for one question. I know you have too many questions, so you want to go to the booth and continue a conversation there. Please do that afterwards. We will continue with our conference. Thank you so much.
Thank you all.